Good day, students. How are you doing? This is me again, Sir Navarro, and welcome to our YouTube tutorial video. In this video, we're going to discuss about all about inverse variation. So this is just a continuation of what we discussed in the last video, direct variation. All right, let's proceed. So yeah, in the class we discussed this already. This example. So inverse variation occurs whenever a situation produces pairs of number whose product is constant. So in the direct variation, it's pairs of number whose quotient or ratio is constant. In inverse variation, its product this time is constant. So from this example, let x be the number of people. So 1, 2, 3, 4, 5, 6 sharing the amount of contribution money each person will pay if the amount of or the price of the pizza is 180. So k there is the price, which means that it is the constant of variation. So we say that x times y, since x times the number of people, the number of people times the amount of money contribution for each people is equal to the constant k price, right? Now there is also one representation of this, which is generally used, y equal to k over x. So this is the common one, this one. But you can still use this. This is to find the k, but this one to find the y, or if you try to replace or find the x. Now, let's try to look into some details regarding inverse variations. For example, let's try to check. This is an inverse variation. We've checked this one already, since the product are just the same. But let's try to see if the given table here is an inverse variation. So the product for this one is 120, and this one is also 120. This is 120, 120, and I don't know this one. Try to check. This one is 120. I think this one is not 120. Yeah, this one is not 120, right? This is 100 and 7, 42, and yeah, 42. Yeah, 112. Correct, no, 112. So therefore, it's not a variation, inverse variation. Let's proceed. So given the graph, you can also check that a given graph is an inverse variation by taking the product for each pair. For example, this point, this is 180, this one is 290, this one is 360. So if you try to multiply each pair, it will always result to 180. And also, if the graph looks like this, so it doesn't touch the x, it doesn't touch the y, right? It's just passing by, but it's not actually passing by. It's almost touching x or y, but it will never really touch the x or y. Alright, so can you check if this is an inverse variation? So let's try. 1 times 90 is 90, 2 times 45 is 45, 3 times 30 is 90. Sorry, 2 times 45 is 90. 4 times 23, there's something wrong. 5 times 18 is 90, 6 times 15 is 90. This one doesn't make sense, no? Because the product is not 90. So therefore, this graph doesn't represent what? What's that? An inverse variation. So the graph of an inverse variation is asymptotic, not asymptomatic. Okay? Meaning to say, it doesn't touch the x and y axis. So it looks like this. If the constant is positive, it looks like this: the first quadrant and the second quadrant. And if the k is or constant is negative, it looks like this: the second and the fourth quadrant. Alright? So given the table of values and graph, we can only say that it is an inverse variation if the product of numbers is constant or the same, just like what I said earlier. So like this. So if x increases, y decreases. If x decreases, y also. Y, like they have opposite trend, Y goes down, the other one goes up. Y goes up, the other one goes down. So the common phrases that are usually used in representing or in a inverse variation statement are these two, no? Y varies inversely as x, or y is inversely proportional to x. This just means that y there is written on the left side of the equation, or it could be on the right side, but make sure that the k and x are on the same side of the equation. Now, what does it mean? There is some number x dividing a constant k daw, which equates to k. Or y is equal to some number x dividing a constant k. Okay? So how do we get that? From this one, xy earlier, x times y equal to k, we just derived it. Then we come up with y equal to k over x. Now, expressing an inverse variation statement as a mathematical statement. The volume of a soft drink per person varies inversely as the number n of people. So V, volume, was written first, inversely equal to k over n, and then k over n. Okay, let's try. The battery health of gadgets B varies inversely as their age A. So B is written first, therefore B is equal to, alright, k over A. Next, this time the equation is given, but you are asked to give a variation statement. This may vary also. So where S is the stock of face mask and N is the number of buyers. So there you can say that there are a lot actually. The stock of face mask is S varies inversely as the number of buyers, and or the stock of face mask is inversely proportional to the number of buyers. Okay. So let's go solve the constant and k and find the equation. So for example, if the number of petchay plants in n in a row varies inversely as the space s between them, and then is 7 when s is 12, find the value of k and the equation of the variation. So now the steps here usually goes the same with direct variation, no? So you can just use those concepts or reuse those steps. So yes, express the inverse variation statement as mathematical equation. So there, since n inversely proportional to space s, so n is equal to k over s. Alright? And then solve for k by substituting the given values in the equation. So you have there the first pair, n equal to 7 and s is equal to 12. So you can say we can now substitute them. 7 is n and then s is 12. So you can just cross multiply or just actually the correct property on that is by multiplying 12 on both sides, so that we can cancel 12 on the right side, and on the other side we can now multiply. So 7 times 12. So similarly, it looks like cross multiplication. 7 times 12. So 7 times 12 is just 84. So therefore, our constant is 84. And our equation of the variation, replacing k here, is, yes, n equal to 84 over s. So there is another way of solving k also. So k is equal to ns. You can just directly multiply them, which is also 84. Either way, you will come up with the same answer. Alright, let's try this time. If g varies inversely as h and g is equal to 10 when h is 2/5, find the constant of variation and the equation of representing the relationship between g and h. Alright, so our first step is to write the translation of the variation statement. G is equal to k over h. And then we replace the g, which is 10, h is 2/5. So there. And then cross multiply. So 2/5 times 10. You just cancel this. This will be 2. This will be 1. So 2 times 2 is 4. So that is why our constant is 4. Or, in short, you can just have it like this. 2/5 times 10 equal to 4 gyapon. So our equation will be what? It will be g is equal to 4 over h. Okay? Do you follow? Let's proceed. Now, n is inversely proportional to m. What is the mathematical statement? Find the constant of variation and the equation of the variation. So there, given ang table, you are asked to give the statement in the constant of variation and equation. So let's try to find the first is the mathematical statement. This is inverse, of course. N is inversely proportional to m, so therefore our mathematical statement is n is equal to k over m. Constant of variation by multiplying each pair, no? If we multiply each pair, we will come up with 7. And our equation will be n equal, replacing k with 7, so therefore n is equal to 7 over n. Okay? Now let's try about with graph though. Graph. D varies inversely as C. What is the mathematical statement? Find the constant of variation and equation of the variation. So there, you can just check, 8 times 42, how much is that? Or 14 times 24, how much is that? Okay, so our mathematical statement will be D is equal to K over C. And then our constant of variation, by multiplying 14 and 24, it will be 336. Okay? So there, our equation will be D is equal to 336 all over C. Okay? Let's inverse variation involving two pairs of values, which may be easy. Okay, so let's just have this one into another video. I'll just cut this one into two parts. Thank you and get